Today we're going to take a look at potential and kinetic energy. This unit is on energy and how energy converts from one type of energy to another. So we're going to look at the energy conversions of potential and kinetic energy and how they move from one to the next. So right now you're witnessing potential and kinetic energy, and in this presentation you should understand how and why these pictures are showing or displaying kinetic and potential energy. So we'll take a look at roller coasters and how that might be used as an example of converting from potential energy to kinetic energy. So we're going to look at all energy. Energy is the ability to cause change. So energy is always changing. Energy is always happening around you. So when we take a look at all energy, it's divided into two categories, potential and kinetic energy. And potential energy actually have a bunch of different types of that, and those would be gravitational potential energy. Gravitational potential energy deals with your position relative to Earth, and we'll talk a little bit more about what that actually means. Elastic potential energy, which deals with things that have the elastic ability to it. And then chemical potential energy, which are energy stored in chemical bonds, which we'll talk a little bit more about. So what exactly is potential energy? Well, potential energy is that energy that is stored and waiting to be used later. So potential energy, or things that have potential energy, they don't move. They don't have that ability yet, but once that energy is released, it will convert to a different type of energy. So if we looked at this picture here of the little boy with the paddle, there is some potential energy in this, and once the ball starts to move, it no longer is potential energy. It's converted now to kinetic energy, which is that energy of motion, which we'll talk about a little bit later. Also here, this person is pulling up this weight. This weight has potential energy, and we'll talk about what type of potential energy this particular weight has on the next couple of slides. So gravitational potential energy deals with where you are relative to Earth. Okay, so when we look at that picture again, it's due to its position. So the higher up an object is, the more gravitational potential energy it has. So it has a greater potential energy, or gravitational potential energy, because it's very high. Now if we lowered this, the gravitational potential energy would then decrease. So the higher up you are above the ground, the more gravitational potential energy you have. So it's the potential energy of an object has due to its position above Earth. So we'll look at this particular example. This mound of dirt, if I were to stand on top of this mound of dirt, I would have a lot of gravitational potential energy. So things that are very low to the ground, so if I were standing on this road, my gravitational potential energy would be very low. So the higher up I am, the more gravitational potential energy I have. So if we look at this dog on this tightrope, Rover, he actually has an increase in his gravitational potential energy because he is high off the ground. So anything that is above the ground is going to have an increased gravitational potential energy. So let's look at elastic potential energy. Elastic potential energy deals with things that have any type of elasticity. So this is going to be due to compression or expansion. So the little boy with the paddle, this is kind of like a rubber band attached to that ball. And so if we stretch this and then let it go, we would convert from elastic potential energy to kinetic energy. So the more we pull this, the more kinetic energy that particular ball is going to have. So if we look or notice, the ball is compressing and expanding. So if we look at this diagram, if we're bouncing that ball back and forth, the ball is compressing once it moves towards the paddle and expanding once it moves away from the paddle. So elastic potential energy deals with energy due to its compression. Let's look at another example. So if we look at a rubber band, the more you're going to pull that rubber band, the more elastic potential energy it will have. So if you were to shoot a rubber band across the room, which I hope nobody would try, you would pull it as much as possible, and pulling it very tight, you're going to shoot the rubber band farther. So you're going to increase that kinetic energy of the rubber band. And the last type of potential energy we're going to talk about in this presentation is chemical potential energy. Chemical potential energy deals with the energy that's stored within the bonds of things. So if you take a look at this example, this is a piece of coal. A piece of coal has lots of chemical bonds stored in it, and if we burn it, we're going to produce some energy. So we use coal to make or to produce energy, especially in power plants. So they burn coal to run trains. So those chemical bonds that are stored here are going to produce energy for that train to move. So it's the energy stored within the bonds of an object. Also, if we take a look at another example, batteries are going to operate tons of things. So those chemical bonds that are stored within these batteries here are going to make this flashlight work. So the chemical bonds that are stored within things are going to produce energy for us. Another example, which is not, I don't have any pictures of, would be food. Food has stored bonds in it, and when we eat it, we actually use those chemical bonds or that potential energy for our body parts to work. So basically, we eat food for energy. So we use the chemical potential energy of food to then convert it to kinetic energy. And last but not least, we're going to talk about kinetic energy. Kinetic energy is the energy an object has due to its motion. So we're looking at examples of potential energy and how potential energy could convert to kinetic energy. So if we were to cut this line here, this potential energy, which was gravitational potential energy because it was very high off the ground, would then be converted to kinetic energy. Remember, the higher up this particular weight is, the more gravitational potential energy it has, and the more kinetic energy it's going to have as it falls down. Now, as it goes down, it loses, or the kinetic energy starts to decrease, and that potential energy then would also decrease there, or the gravitational potential energy would decrease because of its position relative to the ground. So if we look at roller coasters, as kinetic energy increases, potential energy decreases. So here, our potential energy is very high. And as we roll down the roller coaster, the kinetic energy increases. So every time we're high off the ground, our kinetic energy kind of goes up. So it kind of bounces back and forth. So remember, we're high off the ground, our potential energy is then converted to kinetic energy. As that converts, these levels start to change places, so the kinetic energy will increase as our potential energy decreases. Same thing with a person skiing. The higher up they are on a hill, the more potential energy they'll have, and as they come down the hill, they're going to increase in their speed. So their speed is going to go up, and their potential energy then decreases because they're moving. So the potential energy is high at the top of the hill, and it starts to go down as the kinetic energy increases. So they're going to be moving at an extremely high speed as the height goes down.